Okay, let's have a look at question 5. Okay, so question 5 is dealing with a hyperbola. Okay, so what we have there is the function g of x, which equals a over x plus p plus q. Okay, so with these functions, it is important to remember that for hyperbola, this back number does not represent the y-intercept. Okay, so that's important. Alright, why? Because x cannot be 0. Then they also give us the additional information. They say the domain is where x is an element of real numbers, excluding negative 2. X-intercept is at k 1 and 0, and then the y-intercept is at n, which is 0, negative a half. Okay, now 5.1 says show that the equation of g is given by g of x equals to negative 3 over x plus 2 plus 1. Okay, and that's for 6 marks. Okay, so nice portion of marks there out of 12, half the question. So how do we go about doing this? Well, there's 3 unknowns. Okay, so we're going to need 3 equations essentially. But the first piece of information they gave us was the domain. They said x may not equal to 2. Okay, negative 2, which means that we know that x plus 2 may not equal to 0. Aha, so x plus 2 may not equal to 0. So the first thing we have found is we have found the p-value. Okay, so the p-value we know is then equal to plus 2. Okay, that's quite easy over there. Okay, remember x not equaling to negative 2 indicates our vertical asymptote. Okay, because that x value may not exist. Then the next thing we need to do is we actually use the formula. So substitute p into the formula, and then we need to solve for a and q. Okay, so they've given us 2 coordinate points here, so we're going to solve for a and q simultaneously. So the first one we have is when x equals to 1 and y equals to 0. So we have 0 equals to a, 1 plus 2 plus q. Okay, where did the 2 come from? We found p was equal to 2. Okay, now the second equation we are going to create is the equation from the endpoint over here. Okay, so we know that when x equals to 0, y equals to negative a half. Okay, so now we have negative a half equals to a all over 1 plus 0 plus q. Okay, so that's our second one. Now we have 2 equations, 2 unknowns, we just solve simultaneously. Okay, so let's sort out this one over here. So we are going to then take q over. We have negative q 1 plus 2 equals a. Okay, so that means we have negative 3q equals to a. Yeah, there we go. All right. Now that we have that sorted, we know what a is. We can plug it into here, and we can solve for q. So we're then going to have negative half equals to a, which is negative 3q all over 1 plus q. Okay, so then if we sort all that out, we are then going to see negative q plus q gives you then negative 2, so we have negative a half equals to negative 2q. Okay, and then if we divide by the negative 2 here, we end up with q equal to 1. Okay, now that we have q equal to 1, we can just substitute it back into here and solve for a. So therefore negative 3 times 1 equals a, so a equals negative 3. Okay, so therefore we have g of x is then given as a, which is negative 3 all over x plus 2. Okay, that's p's value, and then we have plus 1 for q. Okay, so these give you your asymptotes. P and q are your asymptotes. Alright, now 5.2 says write down the range of g. Okay, so for which values, okay, remember range means all the possible y values that we can have. Alright, so if we look at the function or general setup of a hyperbola, okay, the parent function looks something like that. Okay, which means we go from negative infinity, we don't include the x axis, and then we go up to positive infinity. Okay, so same thing's going to happen here. The only thing is what's limiting us, it's going to be our y asymptote, okay, which is this value over here, the plus 1. Okay, so we can see that all that's happened, we've shifted the graph up. So what we technically have here is the graph is now sitting, let's say, somewhere here for the y transformation. So we're going from negative infinity all the way to positive infinity, and we don't include 1. Okay, so y is an element of real numbers, okay, where y does not equal 1. Okay, pretty straightforward to solve that one. Alright, now 5.3 says determine the equation of h, the axis of symmetry of g, in the format of y equals mx plus c, where m is greater than 0. Aha, important information there. M must be greater than 0. Okay, now whenever we find the equation of the line of symmetry, okay, we always look at two scenarios. Okay, why? Because if we look at a general layout of a graph that has shifted, let's say this is my new point over there, and we have that there, and we have that there. Okay, the lines of symmetry will always sit at a 45-degree angle. One will be negative and one will be positive. Okay, so this one will be where m is less than 0, and this one will be where m is greater than 0. So we know we're looking for this line over here. So we need to solve y equals to m plus c. Okay, now we don't have to work out the gradient because we know that the gradient of a 45 line is always 1. Okay, so, sorry, not m, that should be x. Okay, so all we have to do is find the c value. Okay, and how do we do that? Okay, well, in order to do that, we can use the coordinates which were given to us. Okay, which coordinate are we going to use? Okay, it's not really given to us, you have to then figure it out. You have to use the coordinate of that center point there. Okay, so we know that the function has shifted 2 units, okay, in the x direction and 1 unit in the y direction. So how many units has it shifted in the x direction? Well, it shifted 2 units to the left. Okay, so that asymptote, okay, this doesn't represent that function. So the center point now for the graphs now become it is -2 in the x direction and 1. Why? Because the graph shifted 2 units to the left and 1 unit up. Okay, so that becomes the center point of my 2 line or asymptotes. Now that we have that, we can solve for c. So therefore we just plug those values into that equation. So then we have that 1 equals to -2 plus c. So c equals to 3. Okay, pretty straightforward. Therefore the line or the equation is y equals to x plus 3. Remember, m always equals to 1, the gradient, because of a 45-degree line. Okay, alright, then 5.4 says write down the coordinate of k, the image of k, write down the coordinate of k prime, the image of k reflected over the h line. Okay, so what's happened? If we just draw a rough sketch of this graph, so at -2 we have an asymptote, and at 1 we have an asymptote over there. Okay, and then we have the function sitting here and the function sitting there. Okay, sorry, it's negative, so it doesn't look like that. Apologies for that. The reason being is if you substitute, let's say, your first value into x, this is going to become a negative number. Let's just have a look there. Okay, but the main point is I just wanted to show the asymptotes. Okay, so we have that asymptote over there. We found the line of h, which is the positive one. Okay, and now we're reflecting the point k equals to 1 and 0. Okay, so x must be 1 and 0, so that point over there. We're reflecting it over this line, so we're essentially folding our paper over. So how are we going to find that point? Okay, so we know that the line is x plus 3. Okay, so in order to find that, okay, is there -1, positive 1 and 0, and we need to then find its image reflected over that. Okay, so how do we go about doing this? Well, when we reflect this up, that's going to go directly that way over there. Okay, we know that the gradient is 1, but it has a y-intercept of 3. Okay, so in order to get this, remember, when we reflect it over, your y value now becomes your x value, and your x value becomes your y value. Okay, when we do reflections. But this has shifted 2 units left and 1 unit up, so we have to take that into account. So originally the h line would have sat there, which means when we reflected it would have just been there, so it would have been 0 and 1. But now we have to take into account the shift left and the shift up. So how many units did it shift to the right? To the left? Well, that is from here it shifted 2 units, so a total of 1, 2, 3 units to the left. So your x value is -3. And how far did it go up? Well, it then went, let's see, it went 1, 2, 3. It would have been 4 units. Why? Because your new asymptote is now sitting at 1. Okay. Originally, this would have, it cut up there. So now we've shifted it 4 units up. Okay. So just playing around with it in that case to figure out where it's gone. Okay. You've taken 3 units from here, your y-intercept, but because your asymptote shifted 1 up, you have to include an additional 1. Okay, so therefore k prime is given as that. Alright, and that's how we do this video. Okay, if you guys are finding the content helpful and you are enjoying the content, then please do leave a thumbs up on the video. It does help me out a lot. If you have any questions, leave them in the comment section below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.